folks. Good to see everybody. Hello, hello. Thanks for being here. So my presentation today is called Managing the CS50 Classroom. Let me tell you a little bit about myself. So my name is Duglass Kiangs. I teach at Menlo School. I'm a computer science teacher. But I actually started my teaching career teaching kindergarten. Right now I currently teach CS50 AP. So that is the Harvard's Intro to Computer Science course. So Harvard it's one of the most popular courses at Harvard. It's a programming course for people who don't know how to program at all. So if you're just a complete beginner and you're interested in computer science at Harvard, you take CS50. And they have adapted it and made it available to high schools now. And they have also aligned that course with a very popular set with a framework, a set of standards, computer science standards called the AP framework. And so that's what we teach at Menlo School. And I also teach an app design course for creating apps for iPhone and iPad. So I was a teaching fellow at Harvard in 2017, so I taught CS50 at Harvard. And then I was teaching it in Honolulu, where I'm from, at a school. And I'll show you lots of examples of students at Punahou School, and then I moved to the Bay Area a few years ago, so I'm teaching right in the heart of Silicon Valley at Menlo School. Same thing, CS50 AP. And this AP course, so there's two AP computer science course programs in the United States. Well, it's a worldwide program. AP stands for Advanced Placement, but it's basically college-level curricula that are taught at high schools. And one of the courses is called AP Computer Science Principles, and then the course after that is called AP Computer Science A. The Principles course is really the newest computer science advanced placement course, and it's designed for students, again, who are complete beginners. And I was on the development committee that created that course, so I worked with the College Board as a teacher to kind of help them create this course that's now one of the most popular computer courses in the United States in high school, and actually around the world as well. So anyway, that's a little bit about myself. This is our school. At Menlo, we offer 4 years of computer science in the secondary school level. So kids ages 14 to 17 can take up to 4 years of computer science at our school. And everybody starts with CS50. So everybody starts right at this top part right here. At CS50, CS1, we call it. And it's basically foundational concepts and skills. But the thing about it, because most of the kids who take that are 14 years old, it's their first high school course, we also teach them about time management and about managing deadlines. The Harvard CS50 program basically works on the idea of problem sets. So they give you a really difficult big problem, and you have about a week to work on it. And in our high schools, when kids are 14 years old, a lot of the time they're still being given homework every night. Every night, read pages 33 to 38 and then do these questions. And so they're used to being told exactly what to do for their homework for each night. And CS50, because it's based on a college course, we don't give them nightly homework. We say, here's this problem set, this is due a week from now, but you have to work on it a little bit each night. And that's challenging. Kids will start the course and they'll wait 6 days to start it because they know it's not due for a week, and then they'll be stuck and there's no way to turn it in on time at that point. And so learning time management skills, that's one of the big things that we teach our kids. And what I want to give you a sense of in this talk is a little bit about how we manage to teach all of these different things for kids and how we scaffold it for kids, how we set it up in a way that helps them be successful but also helps them learn those skills that are we think of them as skills that are above learning to program. Because learning to program is just one skill, but above that is project management, communication and collaboration skills. Those are the really important skills that we think are going to serve our kids well, even if they don't end up taking another computer science course. Learning how to manage your time is really, really important. Now, after that, they have a choice. Some kids decide that they want to learn how to build things, and so they'll go here and they'll learn about how to create apps for iPhone and iPad, And then some kids will go on to independent study. So I had one student who created an app as a junior, as a 16-year-old. And then in his last year in high school, he chose to do this independent study, which means he works on his own, and he continued to improve the app and test it, and then eventually put it up on the App Store with Apple. And so that was a 2-year process after he finished CS50. Other kids go into more depth in terms of computer science, so they'll go in and they'll study data structures, they'll study computational complexity, and this is very project-based. And this is a second advanced placement course, so it's taught in Java. And after that, we have an advanced topics course where we have a rotating set of subjects. So last year, we taught machine learning and artificial intelligence. This year, we're teaching web development. And next year, there's so much interest in AI, we're probably going to go back to teaching AI. But we have some students who will take this 2 years in a row. So we offer a rotating set of topics. So that's a little bit about how computer science works in our high school. About a year ago, when we looked at the students, male versus female students, we still have a majority are male students, but we have about 40% are female. And that's very encouraging because it used to be much lower. And we're really working towards 50-50. We want to get an equal representation of male students and female students. You know, this is separated by grade level. So 14-year-olds are in 9th grade, 15-year-olds in 10th grade, 16-year-olds in 11th grade, and 17-year-olds in 12th grade. And you can see most of the students are 9th graders, and they're just starting out. But if they want to take any other computer science course, they have to take CS50 first. It's a very rigorous course, but it gives them a really solid foundation in a language called C. And C is not as common a language. It's an older language. All of the modern languages kind of are derived from C. But chances are when kids go on to do a job internship, or if they want to go do work in machine learning or AI, it's not going to be in C. It's going to be in Python probably, or maybe Java. But the reason we start with C is because if you understand how memory works, if you understand how things work in C, it really sets you up nicely to do some of the more modern languages. And the way we explain it is it's kind of like learning Latin. If you start your language study and you learn Latin, if you understand Latin, learning a Romance language like Italian or Spanish or French, it's much easier. And even learning English and other languages, a lot of them are derived from structures in Latin. And so nobody is going to say, well, you know, understanding Latin is going to help me communicate today in Latin. Just like learning C is not going to help you do a lot of programming in C, but you'll understand many of the more modern languages. So the way our classes work at Menlo is they are about 70 minutes, and we meet every other day. So we have 70-minute classes. And so we might do some different things. So on one particular day, for example, they might come in and we'll give them a paper and pencil exercise. It takes about 10 minutes. They're not on the computer. It's just write down, you know, show some examples. Think about as many different examples of iteration as you can possibly think of. Or we'll bring something back from the previous class and say, do you remember what this is? In your own words, explain what this is doing, what this code is doing. And that takes about 10 minutes. And then in about 20 minutes, we might spend working in what's called the sandbox. And the sandbox is an area where students can write code, and they can immediately compile their code and see how it works. And so we'll give kids hands-on experience in doing some different things that we're going to ask them to do in the problem set work. And then we'll introduce the problem set, and we'll have the rest of the class, like 40 minutes, to just work by themselves or work with other kids in the class. And for me as the teacher, I'll circulate it, I'll walk around the classroom and help students with their work as they get started on the problem set. And then the next time they come back, we'll do a quick review and assessment. Maybe they'll take a quiz. Maybe they'll do another paper-pencil practice. But the rest of the time, about an hour, they're spending working on the problem set. So if kids make good use of their time in class, they should be able to get a lot of work done on the problem set in class. So that's kind of the plan. So that's sort of 2 example classes in the way that we kind of run them. Today I want to talk about 6 things. I want to talk about how I structure a lesson. I want to quickly go into this idea of belonging and how we make sure every kid feels like they belong. We're going to play a game, and I'm going to talk about how I handle late work. I'm going to show you some tools that we've developed that kind of help you grade and score problem sets automatically. And finally, I want to talk a little bit about how we give kids feedback that helps them improve. So let me jump right into it. So the lesson structure, first of all, this is kind of how I structure a lesson. I think about it in 3 parts. An unplugged activity, what we call a birdhouse activity or a guided activity, and then an independent project where they apply the skills that we know that they have developed. So let's talk a little bit about an unplugged activity. So when we say unplugged, typically we mean it's not on the computer. So it could be a paper and pencil activity, or it could use cards. So here's an example where we give kids 9 slips of paper, and we have on each piece of paper we have a number from 1 till 9. And we ask them to start at one end, and we want them to swap the numbers on either end with their counterpart. So the 1 and the 9 will switch places, and now we move to the next number, the number 2, and we want to swap the number 2 with its partner. And then swap the number 3 with its partner, and the number 4 with its partner. And when we get halfway, we notice that the order of those cards is now completely reversed. But if we continue, so we go on to the 4 and we swap the 4 with its counterpart, and then we swap the next one, and we swap the next one, and then we swap the next one, we end up with the same order that we started with. So we have the kids write down, like, what did you notice? Because you want them to notice 2 things, that at the midpoint, the order is reversed, and at the end, it's gone back to the original order again. And the reason we're doing this is because the problem set has them writing, and this is a CS50 problem set called filter, where kids are going to bring in one graphic, and they're going to write code that swaps the graphics so it looks reversed. But what happens a lot of the time is kids will say, well, when I did this, nothing happened, nothing changed. The picture came in, and I ran my code, and nothing changed. It was the same picture. And the reason for that is because one of the most common mistakes that kids make is they basically set up their nested loop to go with number of times. So they'll set it up this way. And what this means is that inner loop, this is what swaps the numbers. It goes all the way to the end. So in fact, it's swapped about halfway, and then it ends up swapping everything back again, the same way that they found with the slips of paper. So this actually should be J is lesson width divided by 2. But we know that that's a common mistake. And so we've set up this unplugged activity to kind of walk them through so that when this happens, and this will happen to a number of kids, they'll realize, oh, wait a second, that's right, we did that activity. So that's kind of how we set up the unplugged activities to support the activities that they do later on. And we have a piece of paper, and we give them the cards, and we say, okay, here's the index of the left number, there's the index of the right number. What happens? And I want you to actually literally write down the order of these numbers as you go. And so we've created all of these paper worksheets, and I have a folder that I've shared where, and I can give you the link, but all of these daily checks are in there, and this is one of them. And then we ask them to explain in their own words what happens when you start at 0, continue to the end, when is it fully reversed, and what happens when the number of elements is even. So these resources are all right here, tinyurl.com/cs50educators. It's in the daily checks folder. And if you go to that folder, you're going to find daily checks that we've created for every one of those problem sets. There's a whole bunch of activities, and they're all just designed to be printed out on paper and have the kids work on it. And literally what I do at my classroom is every kid has a folder with their name on it. And when they do the daily check, they put it in the folder. And then they keep the folders in my classroom. So they know when they come in my room in the beginning of the class, first thing they do is they put their phone down and they take the folder and they leave their phone at the front of my class, because I hate it when kids are always on their phones during class. So I've done from day one, the kids are used to just dropping their phone off and then picking up their folder. And then sometimes what I'll do with the folders, since it has their name on it, is I'll put the folders at random places so that the kids don't always sit in the same place, because I want them to sit with different kids. So I'll use the folders as a way of scrambling the seating assignments. But you know, by the end of the semester, all the work that they've done, it's all in the folder. So when they want to review, they just go back through the folder. So that's kind of how I use it. But again, inside each one of these folders, there's all the daily checks. They're all numbered, and there's a catalog. There's like a list of what it is and what they test. This is a spreadsheet. So everything that is tested in each of these is there. So you can use any of these. And it's fun. Create your own too. Like I'm creating new ones all the time. So whatever works for your students, feel free to create those. So that's the unplugged activity. And then we go to a birdhouse activity. And the idea of a birdhouse activity really is, it's kind of like when, I don't know if you ever took wood shop, if they ever taught wood shop in class, everybody kind of makes a birdhouse as their first project. And the nice thing about the birdhouse is if every student is making the same thing, it becomes really easy to assess, because you can look at it and just say, well, does it look right? Because you know what it's supposed to look like. Right? If the roof's a little crooked, then you can say, oh, the measuring skills are wrong or the cutting skills are wrong. So that's a birdhouse activity, right? It's everybody's making the same thing. Well, the problem is most schools stop after the birdhouse activity. They say, okay, we've taught the skills, we've assessed the skills, now let's move on to the next unit. The important thing is to follow up the birdhouse activity with an independent project where kids can exercise some creativity and use those skills in a different way. And I'll show you some examples of those as well. But here's a birdhouse activity. Again, everybody's coming up with the same thing. So we use a tool called Sandbox. It's CS50 Sandbox. And it's a place where you can just experiment with code. So I can write a template, and then I can distribute the URL to my kids. So when they open it up, they're opening up a copy of the template. And the work that they're doing is going to be on their own sandbox. It doesn't change the master. So here's an example where we're working on swapping values. So we were teaching about pointers. Here's an example where we are creating a new array. And then we're saying, OK, print it out. And then we want you to reverse the order of the numbers in the nums. So swap the values. And we have them do this in the sandbox. This is separate from the filter problem set. But this just isolates it to that one problem. We're saying, OK, we're already giving you the array. But now we just want you to swap those values. And so the code that they do here, they should be able to adapt that code into their actual problem set. It shouldn't be too hard. But they can't just copy and paste it as is. They're going to have to change it a little bit, which means they have to understand it. But that's the concept behind this. We've also done this with a two-dimensional array. So we'll say, here's a two-dimensional array, reverse all the numbers. So again, they can build off of the skills that they've already demonstrated, but now they're taking it down to a two-dimensional array. And this will be important with looking at a two-dimensional image, for example, where you have rows and columns. These you can just share. And so if I give kids that bit.ly, they're going to open this up, and they're going to open it up at the point where I shared it. And so from that point, when they open this up, it opens up a copy for them that is not linked. So when they do their own code, it doesn't change this part. This is the master. So I use this all the time. Now again, when we talk about birdhouses, remember that there's not too many different ways to differentiate them. So we want to really do independent projects, because independent projects are really high in creativity, but they're low on new skills, right? Because we're asking them to just demonstrate the skills we already know they have, but in a way that is creative and that makes sense to them. So where we go after this independent project is we give kids the challenge to make something that's artistic. And so modify an original photo using code. So they're going from the filter problem set, and normally actually this is our own twist on it. CS50 goes on from filter to the next problem set. We actually put in our own assignment after filter to say modify an original photo and then explain what you did in your own words. And so kids will use code, and this is one of their favorite problem sets of the year, because they don't have to learn any new skills, but they're taking those skills of reflection, changing the colors, things like that, and they're applying it in their own combination to make something unique. And so I had kids share it on a Padlet, and so these were all created by students, and they're all really unique. And kids sort of thought, you know, here's the effect that I want. And because they have to explain it in their own words, I know that they understand the code that, that goes into this. So, you know, if we're concerned about ChatGPT and about kids cheating using ChatGPT, it's a lot harder to have them decide, you know, explain in your own words, why did you choose this photo? You know, what does the code actually do to change it? I mean, it becomes a lot easier to see the kid's voice when we're giving them an assignment like that. So I guess that would be my challenge to you, is to say, go beyond the birdhouse. Let's definitely teach the concepts and teach the skills and assess the skills, but see if you can find ways in your curriculum to create opportunities for kids to do independent projects about things that they care about. All right, so I'm going to talk a little bit about belonging, but actually this is going to get a little bit into the next presentation after this. I'm going to go into much more detail about this. So here's what I'm going to be talking about kind of more next time, is that what we're trying to do is create a sense of belonging for both boys and girls in the classroom. And what's more important than the teacher is actually whether you're reinforcing current stereotypes, is what the research is showing about that. We actually put this message out, like I write it right on the board as soon as they come in on the first day, that, you know, you belong here. And that's the important message. I want students to see that as many different ways as possible, that you do belong here. We have laptop stickers that we printed up that say CS1, so students who are in CS1 is like our CS50. They put the laptop sticker on their laptop, so when they're going around into other classes, if they see other kids with a sticker, they know, oh, you and I are in the same class. We're trying to build a sense of community. We give out fortune cookies that the fortunes say you belong here, so we try to have fun with it. And when things get tough, we ask kids to repeat these three things to themselves. We say, let's all say this together: I'm smart, I'm resourceful, I belong here. I'm smart, I'm resourceful, I belong here. And that's the message I'm trying to tell them. You are smart, you are resourceful, and you do belong here. Every single one of you belongs here, and you're in the right place. And the reason why we have kids repeat this to themselves is because computer science involves getting stuck a lot. You're going to be working on something hard and you get stuck. And when that happens, a lot of the time there's a little voice in their head. It's even in my head sometimes that says, I'm not smart enough to do this. I have no idea what to do. And I have no business even teaching this class because I don't understand this. And so I find myself having to tell myself all the time, I am smart, I am resourceful, I belong here. And so I'm trying to reinforce that with kids as well, because there's power in repeating those words to yourself. This idea of belonging has two components. Do I fit in? And do I have what it takes to do the work? And so a student's perception of their ability depends on how they would answer each of those questions for themselves. Next time, in the next session, I'm going to talk about these strategies, but basically this is what the research and our own experience has shown. If we want to encourage more girls and minorities to take CS, these are the strategies. Positive role models, showcasing student success, educating the adults in the community about what computer science is, emphasizing context over tools, finding ways to build community, and then fostering a growth mindset. So those are the main strategies that, that we have found actually work. So I think that I'm going to jump ahead to, just in the interest of time, the Explore game. But again, I'm going to go into much more detail about belonging in the next session. So, but with the Explore game, basically the Computer Science Principles course is designed to really talk about context. So it's not just a programming course. It's about where does this fit in the context of society. And so we want kids to explore the beneficial effects and the harmful effects of technology on society and on the people who use it. So the AP Computer Science Principles course, part of the assessment is a multiple choice quiz. And so some of the quiz questions have to do with things like computing innovations. And this is a sample question of what a computing innovation question might look like. So if we have an app called Freebird, and it collects bird sounds, shares them with other users. When a user records a bird call, they can choose to share it with all the users on their contacts list. Which of the following is likely to be a harmful effect to users of the app? Sharing the user's location without their knowledge, sharing it with users who are not in their contact list, seeing ads, or risking having their personal information stolen. So a big part of our course talks about questions like this. Now the answer to this one is actually bird calls may be shared with users who are not on the contacts list at all, because it automatically shares it with everyone within a half-mile radius. So we want kids to be able to answer these kinds of questions correctly. And so we do teach about, there are all these new technologies coming out. We want them always to be thinking about what are the effects that this might have on users, maybe unintentional effects, unintended consequences, as well as intentional ones. So when I was on the committee at the College Board, we actually brainstormed how to test for this kind of thing, because there are so many new apps that are out there that have all these different kinds of features. And so one of the ideas that we came up with, I created a card game based on this called Mission Feature Feature, and I use this in my app design class. And the idea with Mission Feature Feature is you have a mission, so you have these cards, and they're all designed to have different missions, and you have different features as well. And so I'll break the kids up into groups, and I'll give each group a mission and 2 features. And I'm going to say, okay, design an app that satisfies that mission and uses both of those features. And so kids might come up with this. They might say, okay, this uses a radio tag that broadcasts the location of your lost item. There's an overhead map that scrolls. They're not actually building the app, but we want them to understand, to quickly get in the habit of just prototyping and brainstorming different ideas based off of features. And kids are so creative. With some practice, they get really quick at doing this. So, so this is a fun card game that we'll play. And then one thing that we'll do is we'll actually give kids one of these cards, a beneficial card, a harmful card, or a data card, and we'll hand out one of these cards. And so for your app, you'll have to name, like, what is one beneficial effect on society that this app might have? What's a harmful effect? And then maybe what is a data privacy, storage, or security question that might come up from this? And these are all from the AP framework. So if kids take the AP Computer Science Principles course, we know they're going to be asked to identify for a given technology what are the privacy, storage, and security issues. So this helps them think through that as well. So that's the Mission Feature Feature card game. I want to talk a little bit about how we handle late work. So late work, always a challenge with kids. Kids, they're busy. Sometimes kids are sick. I've been handling all these emails just this week. There was a storm in California a couple nights ago, and a number of homes in the area are without power. So and I'm a programming class, so I've got kids emailing me saying, what do? I can't make the deadline. But we actually have a system that we have in place called the tardies and late system. And this has just made my life so much easier as a teacher, because I don't have to deal with kids emailing me, asking for extensions, and then me trying to decide what's a good extension, what's not worth an extension. So when kids start my class, they have 3 tardies and they have 3 lates on their record. And if they miss a deadline, they have 1 school day to turn the assignment in, and then I'll take away one of their 3 tardies, and then I'll grade it as if it came in on time. And it's an automatic extension. They don't even need to tell me. They just, as long as they turn it in within a school day after it was due. So if it's due on Friday, they have till Monday to turn it in. And they get 3 each semester, and they can't use 2 at once to get a 2-day extension. They don't stack that way. If they miss the tardy deadline, so it's more than 1 school day after it was due, they can use what's called a late. And a late means you have 7 calendar days from the original deadline to turn it in. But it's not automatic. They have to talk to me first to get the late approved. And the reason I do this is because kids who are stuck and they miss the tardy deadline, if they know they have a week to do it, they'll wait 6 days and then they'll just won't even think about it. And then 6 days later, they're looking at the same problem. They're still stuck, and now it's due the next day again. So I want them to come talk with me first. So I tell them, if you're going to take a late on this assignment, you have to come talk to me so that I can approve it. And if you turn it in and you haven't talked to me about it, I won't accept it. And after 7 calendar days, I don't accept the assignments for credit anymore. And before I did this system, the problem was that kids never really knew if they could get an extension or not, because they never knew if their excuse was going to be good enough. The other thing about it is I'd get near the end of I'd get near grading deadline, and I'd have kids with 3, 4, 5 major projects they haven't turned in, and I'm saying, where's all this missing work? And so they spend a weekend, and they kind of cram it all in the weekend and do lousy work just to get it done on time. And then I've got a ton of grading to do right before I'm trying to do my grades. That didn't work for me. Plus, I like to discuss these assignments with kids, and I can't discuss them until everyone's turned it in. So that's why, after a week, my kids, they turn it in. And because the system is very clear, I don't have problems with kids turning in late work anymore. So they have 3 lates, they have 3 tardies. They know that they have these extensions available to them no matter what happens. And I rarely have kids run out. But now they're responsible for monitoring their own deadlines. And the grade that's in my book truly reflects the quality of the assignment. Because before that, I used to take off 10% for every day that it was late. But then when I look in the book, and this one has got an 84%, and this is an 84%, but it was really a 94%, but I took 10 points away because it was like, how do you weigh those, right? But now in my grade book, the grade always reflects the quality of the work, regardless of when it was turned in. So to me, this has solved a lot of problems. And I just keep track of it in my grade book. So each of these kids all have tardies and they have lates. And then as they run out, I just take one away. What's interesting is that extra credit is always an issue in my class because kids want extra credit. A lot of the time they want to do extra credit for assignments that they were supposed to do, but then they didn't do. So then they say, well, is there extra credit? And for me, extra credit is not supposed to make up for work that you were supposed to do. Extra credit is extra. So I realized for kids who want extra credit, maybe they come to an extra lecture or they're very helpful in class, I'll give them an extra tardy. And they're happy about that. Even though a lot of those kids aren't going to use all of their tardies, it's a way for me to give them something extra, but it doesn't affect my grade book in any way. It just gives them some recognition, which a lot of the time is all they're looking for with extra credit anyway. So kids who are habitually late, they're usually not the ones doing extra credit work anyway. So auto commenters, basically it's the idea that, so there's a problem set that we do called diamonds. And so if I put in a number, it's going to basically come out to be the right height. So 5 is going to give 1, 2, 3, and then 2 and 1. If I want an 8-row diamond, you're going to have to duplicate the 2 middle rows. So this is a problem set. We look for these things. So we've broken out, okay, you need to do these things in order to get full credit for the diamonds problem set. And we actually have kids turn the work in on submit. So let me kind of quickly show you this. So kids who turn in the work, so for instance, we're actually going to look at filter. So these are all the kids who turned in filter. And I created a Google Sheet, and I've shared these Google Sheets with you. It's in that resources folder. But our students actually do the grading. So these are my TAs. And so what the TAs look at is they look at the green columns. And so as they go through here, they're checking off, like, was their blur inefficient? Like, if it was inefficient, they're going to put a 1. Did they use too many variables? Maybe they did. Bad comments. So no comments at all. I'll just put a 1 there. Did they make an extra copy of the array? Do they use this external function, which is good? Did they write their own function? Sure. So as I change these, this comment changes on the fly based on you know, if they were, so notice how it says, good idea to write your own function to keep your code clear. If I put a 0 here, that comment goes away. So what my students do, what my TAs do, is they'll actually go through, they'll just quickly look through the code and they'll check all of this off, and then they'll copy the comment, and then they'll go to the student's code, and they'll paste it in at the bottom. So this code, this comment came out of the spreadsheet. I've also trained the kids to actually go through, and when they find things that kids should have done, they'll leave a note for them. And so kids get feedback right away on the code. And this is all inside of Harvard's submit system. So Harvard actually has a course system so that all of my kids sign up, and every time they submit their solution, it kind of goes here, and I can see all the work the kids turned in, and I can see when they turned it in. And then I can leave them feedback as well. So that's that whole process. So it's saved a lot of time. And then what we'll do here is that spreadsheet, depending on how they did on each different things, like if they created their own function, that's a great example of abstraction. We've created 5 different skills that we're grading across the entire school year. Their knowledge of abstraction, their knowledge of code fluency, which is essentially efficiency, correctness, in other words, is it fully correct, how well they're commenting their code, and style, which is how closely are they conforming to style conventions like indentation and brackets and things like that. And we actually give them feedback on a Google Sheet. And so kids keep track of how they're doing overall in each of these fundamental computer science skills. And so that kind of brings me to the last point, which is toward mastery. What we want to do is we really want to talk about, we want to get kids working towards developing the skills of computer science. But the problem is, we find that grades are a very imprecise way to measure that. Because if you're getting a B+, what does that mean, really? In terms of how do I know what I need to do to get better? A grade doesn't really give you a lot of feedback. We find that what's really important is detailed prompt feedback. And we find when we give the feedback and a grade together, students will just look at the grade. They'll ignore the feedback. So we actually got rid of grades in our CS50 class. And this is not across the board. Like the other computer science courses at our school, they're all taken for a grade. But CS50 at our school is pass-fail. And that was the big change that they made when I was at Harvard in 2017. Harvard changed CS50 to be pass-fail by default. And that was a huge switch because they were about the only class at Harvard that decided to be pass-fail. But because they were the most popular class, Harvard allowed them to do it. And what we found was that students got better more frequently. They got much better at coding, and they stopped comparing themselves to each other when you took away the grade. And so we really try to assess all of these different things using, this spreadsheet. And it's made a huge difference. And it was Harvard that did it first. And we were concerned that kids would pull back and not work as hard because it was pass-fail. And in fact, Harvard found that was not the case. Harvard kids continued to work hard. They just had less stress. And we found the same thing true in our high school as well. When we changed this to a pass-fail course, much less stress for the kids. But they still worked hard. So that is about all I have here. I think if you were all in the keynote, you probably remember the story I told about the lemons. That actually was, I've been telling this story before ChatGPT. Because originally this story about this is not a bad orange, it's actually a sweet lemon. To me, when I first heard this story, this story was about kids. And about when we think about kids a certain way, then we start thinking about all of their limitations. But when you get to know your kids and you give them a chance to demonstrate through an independent project something that they care and that they're passionate about, you might find out this kid's really a talented musician. Or this kid is really a gamer. They're a gamer. That's the way in to get this kid really involved and interested. And that's, I think, the special piece that we teachers bring to it. ChatGPT can't do that. Bringing care and empathy to the classroom, that's what teachers do. And the more you know your kids, the better you can place them into a context that allows you to see all the different ways that they can be successful, rather than just thinking of all your kids as oranges. So that's the last kind of point that I would bring up. So again, all of these resources are here, tinyurl.com/CS50educators, and I'm here today. Also tomorrow I'm going to be doing a longer session, about 3 hours of hands-on, so I would encourage you to please come to that if you're interested. Is there a link? If they're interested in coming tomorrow, what should they do, Linda? How do they?
I can send you, since I have your emails, I can send the information. I have already sent to some of my colleagues. And probably the difference between this workshop and tomorrow is that it will be more practical, and also probably you can comment on, we have workshop also on Saturday.
Yes, and on Saturday we'll do a full day workshop really about how to create a lesson plan and curriculum. So I mean, it'll be cool. You'll walk away with something that you can use right away. It'll be something in line with your current practice. So I've been in your shoes. I've been as teacher, sitting in professional development conferences, and you know, I always want to know what is it that's going to be useful. And so I promise you, there'll be something useful that you can take out of this, because your time is valuable, and you know.
I would also highly encourage, because currently from Riga Business School we are translating and localizing, adapting CS50, so it will be available from the next study year. So Duglass Kiangs is for 2 more days, and please join the workshops. And I really appreciate you coming here. And I haven't met people who have taught computer science for 30 years and have a rich experience in teaching methodology, not what to teach, but how to teach. And also what I see from your presentation, the criteria, the rubrics, what we have been talking, and you have real example how to evaluate and assess students' work. So really, this is the time when you can really take maximum, and it's for free. It's for free.
All right, thank you.